Today we're going to take our rational graphs and we're going to talk about transformations. Now I hope you look at this and go, oh, the stretches and compressions and Roxa, and hopefully you'll look at that and remember everything. So remember for our parent function, we talked about the vertical asymptote was x equals 0 and the horizontal was y equals 0 for the parent function. Now over here, I've kind of written an equation for what it might look like. The numerator is going to be your a value. It could be positive, it could be negative. The denominator is going to have your h, and your outside is going to have your k. So remember, negative a makes it a Roxa, reflects over the x-axis, and you take your a without the positive or negative, just the a value. Bigger than 1 is a vertical stretch. Less than 1 is a vertical compression. X minus h is a move to the right. X plus h is a move to the left, still opposite like they've been all year. Plus k goes up, minus k goes down. So these two changes affect your vertical asymptote, and these two changes affect your horizontal asymptote. So it started at 0, but if we move it up, then your horizontal asymptote moved up as well. And your vertical, if I move left to right, it's not going to be at 0 anymore. It's going to move left and right with that transformation. All right, let's try this. We've kind of already done a little bit of this in our last lesson, but let's continue. Transformations. I don't see a Roxa, but I do see an x plus 2. That must mean it's going to the left 2 spaces, and this minus 3 means it's going down 3 spaces. So my horizontal asymptote, which used to be at 0, has now moved down 3 spaces. So y equals negative 3. My vertical, which used to be 0, has moved to the left 2 spaces. So it's at x equals negative 2. And you can use your calculator to help you find these if you want to just confirm your suspicions. But we're going to draw our asymptotes with these dotted lines. Our domain, remember your domain is all real numbers except for the vertical asymptote. X cannot be negative 2. Your range is all real numbers except for the asymptote y cannot be negative 3. So for my graph, I can put it in my calculator if I want to. You're going to learn some of the patterns with this graph. Let's see. So that's a positive 1 over x plus 2, and then minus 3. So there it goes. So you're going to notice with this graph, we look at the table. I want to pick whole numbers. I don't want fractions. Let's see, is there a whole number? There's one. Negative 3, negative 4. So if I go to negative 3, 1, 2, 3, 4. And then on the other side, it's negative 1, negative 2. If there is not a vertical stretch or compression, more likely stretches, from your center point where the asymptotes intersect, it's just over 1, up 1. And from here, you can just sketch your L towards each asymptote. Again, try to draw it approaching the asymptote. Don't let your graph curve back in because that's not what it looks like. But that's it. All right, next up, let's see how this one works. Negative. Okay, there's a reflection over the x-axis. It's a 1. It's not a stretch or compression. Nothing happened there. X minus 4 went to the right 4, and plus 2 went up 2. So my horizontal asymptote right here is y equals 2. It used to be 0. We moved it up 2. Right 4 moved my vertical asymptote to x equals 4. So we draw those first. There's my y equals 2. And now I need my x equals 4. So when I write the domain, all real numbers except for the asymptote. Range, all real numbers except for the asymptote. And remember, your range goes with your y's and your domain goes with your x's. Now, notice this one was a reflection. So instead of being, I call it quadrant 1, quadrant 3, we switched. We reflected. And there's no stretch or compression. So I can just put a point at 1, 1 from the center and approach my asymptotes from there, trying not to cross over those lines. And if you need to look at it on your calculator, you've got that capability. Let's see, -1 over x minus 4, and then plus 2. You can see there's your graph. So there's the left branch and the right branch, and they've switched quadrants because of the reflection over the x-axis. All right, on this page, we're going to continue practicing with our asymptotes. That's a big part of what we're doing here. Horizontal asymptote is the first thing we always look for. You look for your leading terms. We have x over x squared. That's a BOBO, bigger on bottom. My vertical asymptotes come from making the denominator equal to 0. So in this case, I need to factor and find factors of 12 that add up to 8. So that means x equals -6 is one asymptote, and x equals -2 is the other. And then my domain, once I get all this written, it's easy. X, all real numbers, but x can't be either of those asymptotes, -6 or -2. The range, all real numbers, except y cannot be 0. All right, let's try the next one. So for my horizontal asymptote, I've got x to the third over x squared. That's a larger power on top. So there is none. There is no horizontal asymptote. For my vertical asymptote, I need to make x squared plus 7x minus 18 equals 0. So to do that, I need to factor. Are there factors of -18 that add up to 7? It's plus 9 and minus 2. So then what makes x plus 9 equal 0? There's one of my asymptotes. And what makes x minus 2 equal 0? And there's the other one. X equals -9, x equals 2. Each asymptote gets its own equation. Domain, all real numbers, except for the asymptotes. Range, all real numbers, and there is no asymptote, so it's all real numbers. All right, let's look at number 5. My leading terms are -3x squared and 2x squared. Well, that looks like, as far as the powers go, the bottom equals the top. So I'm just going to take -3 over 2, my coefficients. Now for my vertical asymptotes, I need to make my denominator equal to 0. So that's going to require factoring. I see a GCF, so I'm going to take out the 2. X squared minus 2x plus 3 is what's left over. And then I need to factor this. Are there factors of 3 that would add up to -2? Not that I know of, unless this was a typo. Let's pretend like it's a typo and make that a -6, because otherwise it does not factor. So I'll ask the question a different way. Are there factors of -3 that add up to -2? And there are. X minus 3, x plus 1. So my vertical asymptotes would be x equals 3, x equals -1. My domain, all real numbers, except for the asymptotes. And my range, all real numbers, except for the asymptote. All right, let's look at the last one. Now this one's already factored, so we've got to think, if I did multiply it back together, what would my leading terms be? Well, x times x would be x squared, and on the denominator, x times x would also be x squared. So that's in the bottom equals top category. Bottom equals top, divide the coefficients. My horizontal is y equals 1. My vertical comes from whatever makes this equal 0. Well, there's x equals 3. And what makes this one equal 0? -4. Those are my vertical asymptotes. And then once I get those, domain and range should be easy. Real numbers, except for those two values where the asymptotes are. Real numbers, but y cannot be where the asymptote was. So there we go. So lots of practice on those ideas.